Okay, so now examples for the derivative formula. Okay, this contour is in your book. Compute c squared plus 1 squared, and the contour is the following. So I minus I. So a figure 8 with this orientation. Okay, so this is counterclockwise and this is clockwise. I call it C1 and C2. Okay, so yeah, compute this. Okay, so if you want, you can pause and try to do it. All right. Okay, so now, yeah, first step is you have to split this, right? So C1 union C2. And so C1 and C2. But we want both of them to be counterclockwise. That's the what we call positive orientation by convention. So we have to put a minus over here. All right, anyhow. So now let's find each contour. Okay. Right. As always, first find the poles. EIC c squared plus 1. Okay, so what are they? This is easy, right? That's the definition of complex number. It says plus minus I. Okay, so C1, EIC, Z plus I, and then Z minus I. Okay, so in the C1 contour, we have only the pole I is contained in interior of C1. So we can use Cauchy integral formula where this is F. Okay, so this is not, oh, sorry, everything is squared. So, 1 second. So this is squared and this is squared. So, yeah, Cauchy integral formula for derivative. Okay, so 2 pi I. First, let me remind you what the formula is. Okay, so let me put it in a bubble. F prime of Z naught is equal to 1 over pi I. And F of C minus C naught squared. Okay, so that's the formula. Okay, so we have this and then the derivative of EIZ over Z plus I squared evaluated at Z equal I. Okay, so this is the F prime. This is F prime of I. Is that okay? All right, so let's compute this. So first you have to find the derivative. Let me write it for you. All right, so that's the derivative. And yeah, unfortunately, it doesn't have a clean formula. So let me write what the answer is. Yeah, so E inverse. So minus E inverse times 4. And then plus E inverse plus 4. Yeah. Good. So yeah, the answer is 0 for this guy. Yes. Okay. Now let's find the other guy. C2. Okay, this guy is the guy below, and he has a pole at minus I, so only I is inside. And yeah, let's do Cauchy integral. But now for this guy. So this is F. Good. So 2 pi I derivative of EIZ over this evaluated at z equal to minus I. Okay. And yeah, so long story short, this is 2 pi I E minus 2I squared Okay, so let's see how I can simplify this for you. So E comes outside, and you get 2I. And this guy is minus 4, minus 4. So pi E 8 and 4, 2 pi. Okay, so yeah, that's it. So yeah, the total answer is plus 1, 2 pi E. Unless I messed up some numbers here, that should be the answer. Okay, so let's do another example. The final one. compute C+2 for the following two contours, one centered at the origin and one centered at I. Okay. All right. First guy, I think you can see it by now. So we write it in this form because we see that, so this is the contour, and it has two poles, one at 0 and the other one at 2. So only 0 is inside. And we use the formula for derivative. Evaluated at 0. So yeah, a long story short, this is minus 2 pi I. Okay, so that's the answer. Okay, now let's find this guy. Let's draw the contour. It's centered at I, and it has length 3. So 0, minus 1, minus 2. And then 4i. So it's quite big. Okay. But anyhow, so it contains 0, and it contains 2. So 2 is over here. But yeah, you have to check this. So let me check it for you. So what's the distance? So question, is z equal to 2 inside the contour? Okay, let's check. So 2 minus I is what? Square root of 2 squared plus 1, right? Real and imaginary part. And so this is square root 5, which is less than square root 9, which is 3. So yes, 2 is inside the contour. Okay? All right. That means the Cauchy integral formula does not apply. So please do not try it. We have to bring it into that form by partial fractions. C plus 2 is the following. Minus z minus 1 over z squared and plus 1 over z minus 2. Good. All right. So this is z minus I. We split. Okay, and Now let's do Cauchy integral. So this guy is Cauchy integral for derivative. So 2 pi I derivative of minus z minus 1 at 0. And this guy is just this guy is just Cauchy integral formula. Okay, so you just have 2 pi I of constant. This is like f. Okay, what else? Yeah, so let's compute the derivative. So we have 2 pi I minus 1 plus 2 pi I. So minus 2 pi I plus 2 pi I, which is 0. Okay, so that's it. Yeah, so that's the answer to this. Okay, thank you.